So today we are going to work on Leetcode question number 21, merge two sorted linked lists. Basically what we want to do is merge two sorted linked lists and return it as a new sorted linked list. The new linked list should be spliced together by the nodes of the first two linked lists. So here in our example, we start off with one linked list, which is 1, 2, 4, and the other linked list, which is 1, 3, 4. And after passing it through this function, what we get is 1, 1, 2, 3, 4, 4. Let's look at how we can do this first. So here is our first linked list, 1, 2, and 4. And our second linked list is 1, 3, 4. Now, we want to do this in order from the smallest number to the largest number. And one convenient thing about this is that both linked lists are sorted already. So we know that the minimum number for both lists are at the very beginning, and the maximum number for both of these lists are at the very end. So when we compare and try to find the minimum number, we only need to look at the beginning of both linked lists. So here is our new linked list. This is our head, which we will annotate like this. And what we want to do now is compare the beginning of both linked lists. So in the first node is 1, and the first node of the other one is also 1. So we could take either one. We take this one, we put it here. Now we compare the node with the 2 and the node with the 1. We take the smallest value, which is 1, and we put it here. Now we also have 2 and 3 now. Again, we take the smallest value, which is 2, and then 3, and then 4 and 4, we take just one of the 4s. And now because one of the linked lists is completely empty, we take the whatever's remaining in the other linked list, which is another 4. So let's see how we can implement this through code. Well, first of all, let's start with our edge cases, right? What if both linked lists are empty? So if L1 is none, that means if the first linked list is empty and if the second linked list is empty, basically what we will return is none. Otherwise, or else if, linked list is equal to none, then we would just return the second linked list. Likewise, if L2 is none, we return the first linked list. Now we've got rid of those else cases, and now we start implementing our method when both linked lists actually have something in it. So we again have our head here, and when we start off comparing these two linked lists, we start off at the beginning of L1 and L2. If L1.value is less than or equal to L2.value, then we basically assign the first value to the head. So if L1 is smaller, then we assign L1 to the head. And then we move forward with L1, right? So that will be L1.next. For example, in our example here, that's putting L1 here. And then we move L1 to the 2. Likewise, we do the same for L2. Head would equal to L2, and L2 would equal to L2.next. That is, we move L2 forward as well. One thing to remember though is we have a count which actually moves along with our linked list as we append to it. So we want to move count to head for both of these, or you could put both of these outside the if statement, up to you. But count should always be at the very last element of our linked list so that we can append something following that. Now, we don't know how long either of these linked lists are, so we need a while loop. And basically, we want to continue this loop until one of the linked lists becomes empty. So what we have here is when L1 is not equal to none and if L2 is not equal to none. If either of them becomes none, we break this loop automatically. And in here, we do the same thing again, right? If L1.value is less than or equal to L2.value, what we do now is count.next, right? We want to append to next, which is the very last node of our current linked list. So count.next would equal to, count.next would equal to L1. And then from here, we want to move L1 forward again. So L1 will equal to L1.next. And we want count to be the last node of our joined linked list. So we need to move count forward as well. So we would have count is equal to count.next. In the other case where L2 is larger, we do the same thing again, but with L2. So L2 is equal to L2.next. Count again is equal to count.next. And you can have this outside of your if statement if you prefer as well. And now this loop will keep on going until one of the linked lists is empty, right? So now we just need to append whatever's remaining in the non-empty linked list to our joined linked list. So when one linked list is empty, what we do now is we don't know which one is empty, so we need an if statement. If L1 is equal to none, otherwise it would be if L2 is equal to none, and then we also have a case where both of them are empty right away. Actually, that case won't happen. So you could actually have the last one as an else statement, which actually will be cleaner. So let's do that. Because we are appending, we are taking things from each of the linked lists one at a time. One of them would be none before the other. So both of them won't be none at the exact same time. So if L1 is equal to none, then we just take count next and append everything remaining in L2 to it. Otherwise, we append everything remaining in L1 to it. And we want to return the very beginning of the linked list, of our joint linked list, so we just return head. So let's run our code and see what we get. So your input, 1, 2, 3, it matches, so that's good. Now let's try out a couple test cases. Right, first of all, our first edge case, both of them are none. Let's see what we get. Okay, that's good. Nothing shows up. That's expected. Now, what if we have 2, 3, 5, right? So one is empty, the other is not. That's good. Try it with the other one. Try it without one. And we also want to try if it's unbalanced, right? So 3, 4, 2, oops, let's make this a bit more difficult. 2, 4, 5, 8, 101. Let's try that. So one list is longer than the other list. Okay, that's good. And let's just try out with some final numbers, right? Some strange numbers like -1 and 0. You always want to try out with some negative numbers and 0. And it works. All right, so let's submit this and see what we get. So what we have is it runs at 40 milliseconds faster than 40% of Python 3 submissions, which isn't great. And our memory usage isn't great as well. So obviously we can optimize our code for some final things. But in practice, in terms of big O notation, this is basically the fastest that we can go. So finally, let's wrap up with big O and see what efficiency we get for this. So with our method here, what we basically do is we go through each of the linked lists, each of the nodes of the linked list one at a time. And we don't actually have to look back on anything or look at each of the nodes multiple times. So at most, we only need to look at each of the nodes 2 times. So in terms of our computational speed, our big O notation would be n, right? Where n is the number of nodes we have in both of the linked lists. And in terms of our memory, we're not storing anything in particular. We're only storing the full linked list or the joined linked list. And the joined linked list, again, only has n elements. Our big O for both speed and memory is On. This would be impossible to do in constant time. And most likely you probably can't do this in log n time as well. So this will be a satisfactory solution.